back and forth along a straight road. The distance that the car is from a given gas station at time t is given by S of t equals 5 times t plus 1, t minus 3 squared, for t is greater than or equal to 0. Since the distance S of t is given in miles and time, t is given in hours. Okay, so this is going to ask us for S of t and to explain its meaning in context of the situation. So, I'm sorry, S of 2. So S of 2, all you got to do is plug in 2. So finding S of 2 should be pretty straightforward. That is going to be 5 times 3 times negative 1 squared. Negative 1 squared is just positive 1, so you're going to get 15. So we're thinking about the point 2, 15. The x-coordinate, or in this case the t-coordinate, what does it stand for? What does it represent in this problem? It is your time in hours. And the 15, what is it? It is miles from the gas station. Okay, so in this particular case, this means at 2 hours, the car is 15 miles from the gas station. Make sure. Let me look at my solutions to this and make sure I did it. Yeah. All right. So, questions on that? All right. We now need to find s prime of t of 2, which means we got to find the derivative. And really, even if we did know some other rules for taking derivatives, it still probably would not be what we want to do. I can't take the derivative of this like it is. I need to expand this so that I can use my power rule to take the derivative. So I would have 5 times t plus 1 times t minus 3 squared is going to be t squared minus 6t plus 9. And then I need to distribute here. I'm going to keep the 5 out front for right now. So I'll get t cubed minus 6t squared plus 9t plus t squared minus 6t plus 9. If I combine my like terms there, I'm going to get negative 5, or t squared minus 5t squared plus 3t plus 9. And you can distribute that 5. So you get 5t cubed minus 25t squared plus 15t plus 45. Oops, what have I done wrong there? I wrote prime. This is not prime. I have not taken the derivative yet. This is s of t. Let me check my solutions real quick to make sure I've done this right. All right. Yes. Okay. Okay, here. Then to take the derivative, we would get 15t squared minus 50t plus 15. And we need to plug in 2. So S prime of 2 would be 15 times 2 squared minus 50 times 2 plus 15. So that's going to be 15 times 4, which is 60, minus 100 plus 15. And so that's negative 40 plus 15. And that's going to be negative 25. We can see. Okay, so when we have S prime, what is that giving us for this car? It's going to be velocity, right? Because S, whatever S looks like, time is here in hours, and you got miles over here. So when we take the derivative, that's the slope, right? That's our change in y over our change in x. So that's miles per hour. So we could say the velocity of the car is negative 25 miles per hour. What does it mean for velocity to be negative? Opposite direction. So in this particular case, we just know we've got like a straight road, and our reference point is our gas station. So you're like, you could sort of think of it as positive being right or left. In this case, you wouldn't really describe it as right or left. If they gave us more information, it could be like north or south, right? Or east or west, possibly. So if you have a positive direction, you're going, like in this case, to the right. If you have a negative direction, you're going to the left. So the car, in this case, is traveling in this direction at 25 miles per hour. Oh, yes, we probably should put at 2 hours. Yes. Let's put at 2 hours. Because otherwise, we're not showing that we're finding S prime of 2 there. So we do need to put at 2 hours. Thank you. Here for a second. Okay. All right. C wants to know, is there ever a time? Oh, let's see. Okay. Okay. Is there ever a time on the interval from 0 to 4 at which the car reaches the gas station? If so, find the times. So there are a couple ways that you could approach this. This could possibly be like an intermediate value theorem here in this case, but they do ask you to find the times. So I don't think I did intermediate value theorem on the solutions. Let me see. No, I didn't. So this equation gives the distance that the car is from the gas station. So that equation should equal 0 if you're at the gas station, right? So we don't want to use this function that we just found right here where we expanded it. We want to use the original, right? Because the original is already factored for us. If we don't use the original, then we're going to have to factor 5t cubed minus 25t squared plus 15t plus 45. And to do that, you have to do synthetic division and stuff that Coach Wood taught you in Math 3 that you've probably forgotten, right? But we don't have to do that because it already gave us the factored version of this. So we're going to say 0 equals 5 times t plus 1 t minus 3 squared. And basically we just set each one of those equal to 0. 0 equals 5 gives you nothing. 0 equals t plus 1 is going to give you t equals negative 1. And then t minus 3 equals 0 will give you t equals 3. So we've got two answers here, negative 1 and 3. Do we use both of them? Should we use both? We should not. Why not? What? Negative 1 is not between 0 and 4. Very good. It also tells us up here that this equation only applies for t greater than or equal to 0. So we don't want to look at any negative values either, even if they didn't give us an interval here. So we would say in this case the car is at the gas station at 3, or I'm going to do t equals 3 hours because s of 3 equals 0. Everybody okay here? All right. Last part says, is there ever a time on the interval from 0 to 4 at which the car stops? If so, find the times. So when the car stops, what can we say about the car then? Its velocity equals 0, right? If you were stopped, your velocity is 0. So stopped right here tells us that we're looking at when velocity equals 0. And velocity is s prime. So s prime of t was 15t squared minus 50t plus 15. We're going to set that equal to 0. This one, thankfully, we can factor. I would divide everything by 5 first, just to make it a little easier to deal with. So you've got 3t squared minus 10t plus 3 equals 0. And then hopefully this will factor 3t, t minus 3 minus 1, I think will work. And so we will do 3t minus 1 equals 0. So 3t equals 1, t equals 1/3. And over here we'll get t equals 3. Okay, so we would say the car stops at t equals 1/3 of an hour and t equals 3 hours because s prime of t equals 0 at these points. Questions?
Theoretically, be an overachiever and say it stops at 20 minutes or 3 hours.
If you would like it, that would be fine. That would be fine. Yeah, if you did 20 minutes for that third of an hour, that would be fine. That's one of those things like I wouldn't really suggest doing because you might mess it up. You might accidentally say it's 15 minutes, which will make that part wrong. So I wouldn't suggest doing it. I would just say a third of an hour, even though you would never answer me like that if I asked you this real question. But you could. As long as you do it right, you would get credit. All right, let's look at these notes. We're going to do like just a little tiny intro to these notes just to get us going for tomorrow. We're not going to get far enough to do the assignment. Don't worry, I'm not going to try to give you homework from this. I know I do that sometimes, but I'm not going to today. But I do want us to take our last 7 minutes and kind of get an introduction to what's going to happen here. All right, so we are going to use today what is called the product rule. Okay? And so what you have here is another thing that we need to memorize. I need to make you guys a formula sheet so we can have a quiz on it. So this is our product rule. All right, so if we are taking the derivative of two things that are multiplied together, we cannot just take the derivative of those two things separately. Right? If they are added or subtracted, we just take the derivative of the first one, put a plus or minus sign, derivative of the second one. Right? We just take the derivative separately. But if they are multiplied together, we cannot just take the straight derivative. Right? So the product rule tells us if we have the derivative of f times g, then our answer is going to be f times g prime, the derivative of g, plus g, color scheme here, g, just exactly what we have for g, times f prime, the derivative of f. Okay? So what we'll be doing is we'll be using this to take the derivative of problems like number 1 here. You cannot just say this is 2x times negative cosine or something like that. You can't just take the derivative of those two side by side. You have to use the product rule for this. So we would let this part right here be our f and this part right here be our g. So if we're going to find our derivative, we would have dy over dx equals, and then we would have f, so just straight f without taking the derivative of it, just x squared, times the derivative of g. So derivative of g, what's the derivative of cosine? Negative sine x. Then we'll have a plus sign here in the middle. Now we need to do g, just straight g, right? Cosine of x, not taking the derivative, times f prime, which would be 2x. Right? And then so if we write this together, that would be negative x squared sine x plus, we usually write this 2x out front, so 2x cosine x. There's not really much you can do with that. You can't really combine anything there, so you just leave this as your answer. Okay, questions? All right, I want to do one more and then we'll quit. All right, so if I've got the derivative of 3x minus 2x squared times 5 plus 4x, I could just multiply those together and use the product rule, and power rule, which really might just be easier. So that could be the case. But if I want to take the derivative of this, I'm going to let this part be my F, and this part right here be my G. So I would take F, which is 3x minus 2x squared, and multiply it by the derivative of G. What's the derivative of G? Just 4. I have a plus sign. Then I've got to do G, just G, 5 plus 4x times the derivative of F. What is the derivative of F? Minus 3 minus 4x. So then, from here I would need to simplify. So I'd get 12x minus 8x squared plus, over here I would have to distribute. So I'd get 15 minus 20x plus 12x minus 16x squared. And then if I combine my like terms, I get negative 24x squared. And I got 12x, negative 20x, another 12x. So it'll be 24 minus 20 and give us plus 4x. And then the plus 15 on the end. So there's a quick introduction to product rule. You do not have homework on that tonight because we've not done enough of it. So just make sure you have your free response for me tomorrow. Take your time on that. I do have tutoring in the morning. So if you don't understand something about those, come see me because I want you guys to do well on that first one that you've seen before. Okay? Because lots of us are, but a few of us are maybe not doing as well.